Yeah, do the first.
All right, let's get started. Our next speaker for today is Dr. Shu Lin. She's with the School of Electrical Engineering and Computer Science here at WSU. And I'm sure some of you recognize her because you said you took the 425 and cyber forensics and anti-forensics course. And for any of the WC students who haven't taken that course, and you thought the hands-on demo with Dr. Zurieta yesterday was really interesting, this would be a good course for you to take. So it'll go more in depth on cyber forensics. And so, yeah, thanks for joining us, Dr. Lin.
Thank you for the introduction. Hello, everyone. Welcome to my talk. So today I'm going to talk about web browser fingerprinting, the stealth tracking techniques and defenses. Okay, so what is web tracking? Anyone knows what is web tracking? So when we visit a website, we already know that this particular website knows exactly what we are doing, and they collect the information about us. So our online activities are visible to this particular website. But in certain cases, we observe that the information about us and our browsing activities is actually being shared between multiple websites. So this is web tracking. So if you have any questions, feel free to interrupt me during the talk. So let's look at an example of web tracking. So yesterday, I wanted to buy a pair of shoes. So I visited this shopping website. I viewed some shoes, and then I left this website. I closed the browser, and later on, I want to learn about local news. So I visited this news website. So what I found here is this news website show me the ads about the shoes. So these shoes I just reviewed. So how this news website know that what I have been looking for? So this shopping website knows exactly what I'm looking for, but how can the news website know I'm looking for the shoes? So this is a use case of tracking. So the news website depends on the ad revenue. So they want to make money from the ads. They want to serve us the ads that are more relevant to us, that we are more likely to click on it. So they found some way to share my information. So so this is one of the main reasons that web tracking exists. And web tracking can also be used to improve security, and we will talk about it later on.
Oh, thank God. Got it down in the middle.
Yes, sir.
Right here.
Got it. Um, okay. Okay, so speaking of tracking, we need to briefly talk about the traditional format of tracking using cookies. So what are cookies? Cookies are small text files that websites send to our browser and save on our computer. So the next visit, our browser will send cookies to the website, and the website use the cookie to recognize us, to remember us. So one of the use case of cookies is that I'll give you an example of shopping again. So let's say we go to a shopping website and we add some products to our shopping cart. And then we click the website with our purchase name. So next time we visit this shopping website, the website user use our cookies to restore the products in our shopping cart. So it makes our shopping easier. And cookies can also be used to maintain an active login section. So for example, I enter my username and password to log into my banking account. And then the next visit, I don't have to re-enter my data because the banking system can use my cookies to recognize me, to allow me to directly access my bank account. So this is cookies. But of course, cookies can be used for tracking, and there's some privacy issue. So as a user, we can reject cookies. And cookies is the data saved on our browser, so we can also delete the cookies. We remove the cookies from our computer. So in this way, cookie is gone, so the link is gone. So the websites do not have a way to track us, right? Do they? So the websites can still know who you are without cookies. So here is a browser fingerprinting. So what is browser fingerprinting? When we visit a website can use JavaScript to collect the information about our device from our browser. So this device information can be operating system, can be browser, can be various device characteristics. And if we put all this information together, we can build a unique profile for this specific user or for this specific device. And then we can use that to track the user. So browser fingerprints can be easily collected by any website using JavaScript. There's no need to obtain the user consent. And more importantly, there's no data saved on the client side. So there's no data saved on our computer. So there's no way for us to delete the browser fingerprint. So let's look at the process of fingerprinting. So let's say we have a user visit a specific website. The website serves with the web page and with fingerprinting script. And this script will collect the fingerprint, the information about the user device. So these are all transparent to user. And using these fingerprints, the website can identify, can track this specific user. So the question is, what are the fingerprints? what exactly information collected by the website. So that could be information about the time zone, information about the user's device screen resolution, the platform, the headers, the browser type, which browser the user is using, the fonts. So for every browser, there are every device that support a specific set of fonts, and this could be different from other devices. So if we detect the specific set of fonts that are supported on the user's device, we can use that to help us identify the user. And we have canvas fingerprinting. So canvas fingerprinting is more advanced dynamic fingerprinting technique. So the website can have the user browser to draw a specific image like this one. So yeah, I think that. But I don't know if we have.
No way to do that.
Oh, cool. Which page was it?
So those are
Okay, so we were talking about canvas fingerprinting. So what's going on here? Move time. Is there a way to choose
It should go to this one by default.
once I hit the scout?
Don't know why it's moved that way. Yeah, you should.
Okay, canvas fingerprinting again. So, so this is an interesting fingerprinting attribute. The website have the browser to draw a specific image, and this image actually how browser render this image depends on the underlying environment, the software and the hardware of the device. So with our own eyes, we cannot tell the difference across different devices, but we can compute a hash value based on this image data, and this hash value can be used to track the user. And similarly, we can do WebGL fingerprinting. the website can help the browser to draw a 3D image like this one. And again, we can build a hash value with it. And each hash value will be different if the devices are different. And we can also collect the navigator properties to know more about the browser. So if we look at all these fingerprinting attributes, except for these headers, all other attributes, all of these attributes can be easily collected by website using JavaScript. So let's look at a specific example to understand how we can use fingerprinting to track the user. So let's say we have a website, and this website has 1 million web users, and we want to identify Alice. So how can we do that using fingerprints? So we know that Alice is using Mac OS, so she's in this set area. Okay, so we can collect more fingerprints about Alice's device. She's using Chrome browser, so in this area. Okay, so we learned about her device screen resolution. She's using a screen with the width is 1512 and the height is 982. So only a small number of users is using this screen. Again, we detect that Alice's device supports 218 fonts. So let's see, the overlapping area is getting smaller. And at the end, we do canvas fingerprinting. We have a hash value, and this hash value only this portion of users have this hash value. So there is Alice. We identify her. We can track her. So, any questions so far?
How many total different values are used typically in fingerprinting? Hundreds or?
You mean the fingerprinting values or fingerprinting attributes? Like,
The attributes, yeah, like
the
the examples
attributes.
you're giving.
yeah, this is a good question. So, typically there are more than 30 attributes, and we are developing more and more attributes. So what we can use. So browser fingerprinting is actually a double-edged sword. So we can use it for to improve security, and it can also cause some privacy concerns. So let's talk about the good side. So we use fingerprint to detect bots, because the bot's fingerprinting is quite different from human being, human users. So if we use the fingerprint, we can easily differentiate bots and human users. And we can also use fingerprint to improve authentication. Specifically, we can differentiate between a legitimate user and someone who tries to impersonate this user. And let's look at this authentication system. So we noticed that when we logging into some sensitive web applications, especially like banking systems, critical financial systems, they require two-factor authentication. So if someone has our credential, stole our credential, then even they enter the credential, they cannot access our account because two-factor change is present. So they send a verification code to our mobile or our email. So we have to solve this change to be able to access our account. So this is an effective way to prevent account taking overs. But 2FA is not creates friction. So if we have to solve this 2FA change for each login attempt, it's not convenient. So certain websites have this feature called remember this device. So if, so they remember our device for this legitimate login. And so if next visit is from a new device, is from a unknown device, then the website will trigger 2FA change. And if the website notice that the device is the same device is a known device, then 2FA change is skipped. So how websites remember our device? They can use cookies, they can use IP address, and recently more and more websites use browser fingerprints. So let's look at the authentication mechanism that use browser fingerprinting. So we have this user, the user visit the system, the target website system, and input the credential. So the target system have this fingerprinting script to collect the user's fingerprints. So after user input the credential, the website will compare. So the website will compare the user's fingerprint. If the fingerprint do not match, there is 2FA change. So the user needs to solve this change to input the verification code. But if two fingerprints are matched, 2FA change is skipped. So this is we call risk-based authentication. They calculate the risk and depends on the risk. They decide whether or not to present the 2FA change. Oh, my.
Testing.
So I'm looking the images. Yeah.
Any PowerPoint experts?
Let me retry my laptop. Just, it doesn't like my slides. Okay, just do this. From the I have 15 minutes. Okay. So this system is actually vulnerable. So an attacker, let's think in attacker's shoes. Can an attacker somehow trick the website into not trigger 2FA? So that the attacker can bypass 2FA. So in this authentication mechanism, the website use fingerprint to identify the user. So if attacker can spoof the fingerprint into the user's fingerprint, then attacker can can trick this website. So this is a overview of the attack workflow. At the first step, attacker will visit this target website. That's a banking website. So attacker at this stage, attacker will learn what fingerprints are actually collected by this target website. And at the second phase, attacker will track the user into visiting a phishing website. So attacker can have the user's credentials and their fingerprints. So the third and the last stage, attacker use this credential and the fingerprint to log in to access the user's account. So let's see each phase. So the first step, attacker visit a target website. We have this extension to help us to identify what fingerprint attributes the target website actually collecting. So attacker understand that, oh, okay, so this target website actually collects like browser type or system or language, this information. So next step, attacker have this phishing website and trick the user into visiting the phishing website. So at this stage, attacker has the user's credentials and also, more importantly, the user's fingerprints. So at the last step, attacker will use the spoofer extension. I don't see attacker here, so let's see. Where is the attacker? Okay, let's just look at the use this. Okay, so so these are attacker where is ready to perform this attack. An attacker have the user's credential, attacker have the user's fingerprints. The attacker visit this target website, use the credential. Okay, okay, input the user credential, and more importantly, attacker spoof the user, the fingerprint into the user's fingerprint. So at this website, the website compare the fingerprint, and the website found that this fingerprint is a legitimate user's fingerprint. So there's no 2FA change. Attacker can directly access the user's account. So what about the real world? Is this attack actually can be successful in real world systems? So we tested our attack on 14 major websites. So this website, most of these websites are critical financial services. They are major banks, they are major tax websites. So we can successfully bypass 2FA in 9 out of these 14 websites. I cannot reveal the which websites exactly, because a lot of them are still vulnerable to this attack. So here is the question: if the authentication mechanism use fingerprint is vulnerable to our attack, should we just avoid using fingerprint? Do we just not to use it? Should we just use cookies or use IP address? So if we use cookies, we don't use fingerprint. If we use cookies, attacker can steal the user cookie. So as long as this attacker steal the user's cookie, and attacker can access the user account. So the idea is to have a more secure authentication mechanism. We want to combine several factors. Let's say we use cookies and we use fingerprints. So we make the attacker's life harder, because in order to perform this attack, attacker first need to still collect the user cookies. So once they have the cookies, they cannot access our account because they don't have our fingerprint. So attacker have to steal our cookies, and at the same time, they need to collect our fingerprint and spoof our fingerprints. So the more secure mechanism should be we combine several factors to make this attack harder. Okay. So next one, I'm going to talk about the privacy concerns, because the fingerprinting can be used to track users without their consent, without the user's knowledge. And user cannot delete it because there's no data. It's still this tracking. So previously we noticed that the fingerprinting heavily rely on JavaScript. So can we do something on JavaScript to defend against fingerprinting, to protect our privacy? So major browsers and some anti-fingerprinting privacy tools are actually working on it. So what they are using is they spoof some certain JavaScript APIs. So let's say some API can tell us that, oh, user's operating system is Mac, but we report the fake value to the website. We tell the website that the system is Windows, and we are not using Chrome browser, we're using Firefox. So we report fake values to the website. Then there's no way for the website to successfully track us. Okay, and we can even more aggressive, we can entirely or partially disable JavaScript. So for example, the Tor browser, they block the certain canvas fingerprinting API. So there's no return value. So there's no fingerprinting can be collected. Of course, if we entirely disable JavaScript, it will break the website's functionality. But if we want to maximize our, protect our privacy, we can say we entirely disable JavaScript and we sacrifice the functionality. Can we still be tracked? If we just visit a static website, there's only HTML, CSS, we cannot interact with a website because there's no JavaScript. So can we still be tracked? So unfortunately, we can still be tracked. This is one of our work. We developed a new fingerprinting system that doesn't use any JavaScript. So simply visiting a static web page, the website can still identify you. So how this work? So this system is actually based on the observation that different device render the same page differently, depend on the device environment. So let's look at the input field. So this input field look differently in different type of browsers. And if the user configure the system differently, for example, the language is different, then they will show differently on the user's browser. So all these elements will have different dimensions. So if we collect the dimensional data, we can use it to infer the device characteristics and more. So I'm losing the image again. So. Okay. So if we have a variety of these elements, these HTML elements, and using their dimensional data, we can invert, we can learn a lot of information about the device. So, this is our fingerprinting page. Our fingerprint page can be completely, transparent, invisible. So I just show you here, how we arrange this, page. So we have these elements here and we use iframes to send back the elements dimension. So when a different device visit this, page, the elements dimension will be different, and then we can get a different, identifier. So let's look at a fingerprinting process. So first, the user visit our fingerprinting website. So we collect all the, dimensional. We collect all the dimensional data, and using this data, we can build, a unique profile for this user and use it to track the user. Just see
Yeah,
that.
it's not showing up on Zoom. It's not gonna share. I'm not even saying. That's a little suspicious.
I don't know why.
Yeah, it's ridiculous. It's like not really long here.
I think it's the admin, permission, but disable it. Maybe you can, log out the, Could be. Okay, so there's an iPhone screen. So tracking, so some other vectors to be used to track, the user. For example, we can use, browser extensions, because we probably have a very unique set of, extensions installed in our browser that is different from others. So if we have, a set of, if we can learn that what browser extensions this specific user actually install on their browsers, then we can use that to track the user. And this one is, webcams. We can use this small, symbol, on tab, this small, symbol to track user as well. So there are so many different ways to, track user today. Okay, so, in the past, no one knew, who you were. Today it's different. Web tracking is everywhere and is unavoidable, whether you like it or not. So welcome to, modern web. Okay, so I'm happy to take questions. And if you have any question, okay, thank you for listening.
All right, yeah, sorry for all the good stuff happening, but thank you very much.